Hi everyone, today we are going to start graphing sinusoidal functions. Now sinusoidal functions are a type of periodic function that repeat, and obviously the word sinusoidal should sound pretty familiar because of sine, right? One of our trig functions, and that's exactly what it is, okay? Now sinusoidal functions also include cosine because again, cosine, right? It's also a sinusoidal function. All right, so I'm going to try and explain the best I can here in a short amount of time where there is some confusion before we even get into this. So let's go back to our unit circle for a little bit. And I know we haven't talked a ton about this. I wish we had more time to discuss it, and a lot of you didn't get enough of this in grade 10. But the unit circle is a circle that has a radius of 1. I'm just going to draw some stuff over here instead of doodling on the circle over there. So it has a radius of 1. That's why they call it the unit circle, 1 unit. That's defined by the radius. All right, and when we find points on that, right, we can do it two different ways. We can either do the amount of rotations starting from our starting position, which is at 0, 0, right? So, or 0, 0, 0. Yeah, 0, 0 is our center, right? Sorry. But our starting position starts right here at 1, 0. And let me fix that. 1, 0. And then we can rotate, right? And if we have positive rotation, we're heading this way. If we have negative rotation, we're heading that way. So that's one way of defining it. Another way of defining rotation, instead of through angles, instead of through that, we can also describe rotation as a length, which we usually use t or some other letters to describe the length going around the outside. So that's the difference generally when we're talking about radians. Radians are the actual length written. Generally, we like to write them as fractions here so we don't have to write decimals, right, going around. And the angles are when we cut a circle up into 360 degrees. So to do one full rotation of a circle, right, if you're talking about degrees, 360. If you're talking about the length around the outside, it's 2 pi for one rotation around the unit circle. And there's lots of other stuff. We talked about that. You can go back to your notes and read a ton more on it, right? We discussed a bunch. Really important stuff there, okay? So the main thing I want to get at today, though, now, is reminding you about sine and cos. What are the definitions of sine and cos? What are they? They are originally, now they're Latin words, right? Sine, and we won't bore you to death with all that. You can look it up if you really want to read it. But the x-coordinate and the y-coordinate are just these trigonometric functions, which we call cos of the angle, or cos of t, and sine of the angle, or sine of t, right? And that's what sine and cos are. These x and y coordinates on our unit circle over here, if we punch in our calculator, remember if I type in cos of 30 degrees, it's going to give me the decimal equivalent of root 3 over 2. That root 3 over 2 would be the exact value, right? Or let's do one where we won't get a decimal. What if I type in sine of 90 degrees? Well, 90 degrees is right here. Sine would be the y-coordinate, so we'd get out 1. We could also punch in, if we converted our calculator radians, we'd have to switch it over to radians from degrees. But if I put in sine of pi over 2, I would also get 1 because pi over 2 is the distance to go from here to here, right? Sine is the y-coordinate. So remember, sine and cos are literally just the y and x coordinate. That's all they are. That's what they are designed for. Now we do lots more stuff with them, but their original inception in mathematics are the x coordinate is cos, the y coordinate is sine. And that's literally where they come from. When you punch in your calculator, it's just giving us numbers from this circle. That's what it all goes back to. And then we can use it to do a lot more stuff, right? What we're going to do today is we're going to be breaking down this circle. So now, instead of looking at just sine or just cos, so again, the x coordinate is cos. So I'll say cos of an angle or cos of t. And the y is sine, right? There we go. So it's just our horizontal and vertical distances, basically, right? When we set up that right angle triangle, our x and our y. But what we're going to be doing today is only looking at one function or the other. And this is where it gets confusing, okay? So what we're going to do is we're going to be taking information from the unit circle to create new graphs. So first we're only going to look at sine. So what we're going to do is we're going to make a new graph. I'm just going to kind of sketch what it looks like down here. This is our unit circle graph where that's y and x. But y and x are going to represent something different now. So when we start doing these new graphs today, x is going to represent either our radian or our degree measurement. So I'll just call it our angle. Okay, x is going to represent our angle. So x is going to be something like 0 degrees, or 30 degrees, or 45 degrees, or 60, or pi over 6, pi over 4, pi over 30. But normally we like to really use radians here, but since we're kind of away from each other, we're going to focus on degrees for now a lot. So x is going to be like starting at 0 degrees, 30 degrees, 60 degrees, 90 degrees, 45, whatever, right? We'll keep going, okay? That's what x is going to be. The y now is going to be choosing, are we going to graph sine or are we going to graph cos? So we're going to start just looking at sine. This is where it gets confusing. So if I'm losing you a little bit, don't panic, okay? Because obviously I'm rambling on here, and but the y value is going to be either sine or cos. And I know this is where you're getting confused. You're like, but you said x is always cos and sine is always y. Sure, when we're looking at the unit circle, the birth of where sine and cos come from, yes. But now we're going to extract these and just look at one function at a time. So, for example, when we're graphing just sine, if this was sine's graph, what we're going to say is, okay, given these, we're not going to look at the x values here. We're not going to look at what cos is. We're only going to look at the y values. What is y? So as I go to 30 degrees, so I go to x, when x is 30 degrees, right here on my graph, y, which is sine, is 1/2. So I'm going to put a dot. Let's just say this is a half, right? There's a half, there's 1. I'm going to put a dot at a half. And then we go to, let's say, 60 degrees. When y is 60 degrees, or x is 60 degrees, my angle is 60 degrees, right? Oh boy, if you're spinning your head, I get it. So if we go to 60 degrees right here, so let's make x 60 degrees. What is sine? Root 3 over 2, so wherever that's going to be, right? And then we get to 90 degrees. When x is 90, we're going to make x always represent now this. What is sine? Sine is 1, and we get up to 1. Now this will make a little more sense once we start actually graphing these and we look at these separately. Right now I'm just trying to set it up just to kind of get you thinking, okay, we're going to do something different. Okay, so let's move on and actually do that different thing I'm talking about. Okay, so I've got a mini Cartesian plane here with my unit circle on it, and I got a bigger one here where I'm actually going to graph it. So you could use your calculator to figure all these values out, but I'm also going to use my unit circle so we can kind of keep in touch and hopefully start developing our understanding of this a little bit. So x and y. So x is going to represent the distance we go around the circle. Now we can do it in radians or degrees. I'm going to try and do it in both, and I know this might take a little while. So let's start by labeling. This is y, and this is our x-axis here. Okay, so why don't we go, let's put all the points on that we can, or at least as many as we can. We won't get too crazy. No, you know what? I'm just going to go with this. We're going to do 0 degrees, 45 degrees, 90, 135, 180, because if I do everything, it's just going to get way too many points, okay? So let's start with this. Let's make x 0 degrees, and then let's make it 45 degrees. We're not going to look at every possible point. So again, x is now going to represent, it's going to be different. Now sine and cos on your unit circle, x is still cos, sine is still y, but now we're not working on the unit circle. We're going to make a regular graph, and we're going to change what x is. That's the difference here, okay? So let me just make that clear one more time. Now, right, on our new graph that we're making, x, okay, is going to equal our distance around the circle, which is our radians, right, around the circle. Okay, now that's if we're doing radians, right, which I'm going to put a t here because we usually use t for it, or if we prefer to use degrees, and I'm going to talk about them both, okay, or the angle of rotation, which is our degree. They both land at the same place. It's just how do we like to describe moving around a circle. Now most of us are more used to degrees, okay? But those of us that continue in mathematics, degrees tend to be more frowned upon as you get into more complex math. Radians are more accurate and are the standard international way of doing things. So I'm going to write both in the box here. Like 0 degrees is 0 radians. 45 degrees. Well, what's 45? That's pi over 4 radians. So we'll say or pi over 4. So it could be both. This is not a point. I'm just saying it's one or the other, okay? But I'm going to write them both in here so we can see everything. All right, then we'll go to 90 degrees. So let's just start with these first guys here. 90 degrees, and that would be pi over 2, right? That's what I'm getting right there. Okay, so just to fit everything in, I'm going to say here's where 0 is. Let's go every couple squares here just to spread it out. All right, so let's start with pi over 0 degrees. Oh, we already did 0. Okay, 45 degrees. I'll put the 45 on top. I'll write the radians underneath. So we want to kind of get used to using both. I know we're more comfortable with degrees, but just getting used to this, even if we're not perfect at it right now, the better we get at it, the better we'll be at in the future. All right, 90 degrees, right, is pi over 2. You know, might as well keep going. Let's do the rest of our graph here. So let's keep going. Let's go 90. Let's go to 135. So we're going every 45 degrees here. Now we could use any of these points. We use all of them, but I don't want to beat this to death, which would be 3 pi over 4. Okay, I'm going to fill this out really quickly now. In fact, maybe I'll pause. I'll fill it in, and then you can pause it if you want to fill yours own in. Okay, I've completed my graph here. Let's just kind of review what I did. So if I'm counting by degrees, I just decide to go every 45. So I'm just adding 45s every time here, right? We're adding 45 degrees. If we're counting by radians, 45 degrees, every 45 is a pi over 4, right? So I'm going 1 pi over 4, 2 pi over 4, which reduces to pi over 2, 3 pi over 4, 4 pi over 4, right? Again, these are just reducing. 4 pi over 4 is just pi. 5 pi over 4, 6 pi over 4, which reduces, 7 pi over 4, and then you get to 8 pi over 4, which again just reduces to, so that's 8 pi over 4, reduces to 2 pi. All right, so I'm just counting by 45 degrees or counting by pi over 4s, okay? Now, we can, like I've said a bunch of times, we can do more points. I'm just trying to keep it to just some of the points, so there they are. Now, let's look at our y values, right? Now, today we're gonna start with sine here. I'm sorry if I'm rambling a lot. This is a really important lesson. There's a lot to cover. You might have to watch it a couple times. We're gonna make it so that our y coordinates are the sine values. So look at all our sine values, right? Our sine is the y coordinate on our unit circle. So like a half, root 2 over 2, root 3 over 2, 1. We're only looking at the y values here. I'm ignoring the x's because those would be my cos on my unit circle. So I'm just looking at the y values. So what do we get when we do all that? Let's fill in our table here to match up, okay? And then we're gonna do our best we can to graph it. Okay, so when I go to 45 degrees, let's start at our first point, sorry, 0, 0, right? What's the y coordinate there? 0, right? So starting at 0, your y coordinate is 0. Now, if you wanna verify any of this stuff, what you can do is you can punch in your calculator, punch in sine of 0 degrees. Make sure your calculator's on degrees and you'll get out 0. Or punch in sine of 0 radians, you'll still get out 0. Okay, so any of these we can actually do without the unit circle. I could go, what is sine of 45 degrees? Okay, now if I punch in sine of 45 degrees, what would I get out of my calculator? Oops, let me get this all out of here. Sorry, a little looser lesson than usual. So if I punch in sine of 45 degrees, let's just highlight the things we said. Okay, so we got 0. 45 degrees, I would get out root 2 over 2. Now your calculator would give you the decimal equivalent of it, but it would give you the decimal of root 2 over 2. Let's go to the next one. Let's go to 90 degrees. So if we punch in our calculator sine of 90 degrees or sine of pi over 2, it will spit out 1. And keep going, right? All right, what if we punch in our calculator sine of 135 or sine of 3 pi over 4? It will give us root 2 over 2 again. So we'll start noticing once we finish, there's a bit of a pattern to this. And the more you do it, the more comfortable you get with it. Let's keep going. So what if we punch in sine of 180 or sine of pi? You will get out 0. So all of this could be done in the calculator without even looking at the unit circle. Let's keep rolling, almost done. Sine of 225 degrees, the y coordinate is negative root 2 over 2. So this is what sine is. Let's do the next one. Sine of 270 degrees or sine of root 3 pi over 2 in radians will give you negative 1. All right. Coming around, sine of 315 or 7 pi over 4 will give you negative root 2 over 2. And finally, you get all the way back to sine of 360 or 2 pi, and you get 0 again. All right, so there's all the points we're going to get. Now let's try and graph this the best we can. Now the first problem is, a lot of you are like, well, how do I graph root 2 over 2? Let's just go over here. Let me bring up my calculator, and let's see what we get for that. So that's just going to be a decimal, and we'll graph it the best we can here. All right, so I'm just going to go, what's the square root of 2? If only I knew where my square root button is. There it is. Square root of 2 divided by 2, and it's like 0.707. So let's just say it's about 0.7. And we'll just kind of graph that at the best we can here. All right, because a lot of these points are decimals, other than, same with our unit circle. Remember how we just got tons and tons and tons? Everything is a decimal, right? Because what's the highest it can go? What's the highest y can go here? 1, right? That's the highest y can go. What's the lowest y can go? Negative 1. So our graph has a maximum and a minimum, or a peak or a trough, right, of 1 and -1, which is going to affect our range over here when we talk about that in a bit. All right, so to graph this, I'm going to really stretch out the X scale a little bit just so I can fit everything in. So I'm going to go 1, 2, 3. I'm going to make this as a half, and this is going to be 1, because that's the highest we go is 1. And I'm going to go down to like -1/2, right? 1, 2, 3. We'll go right there as -1/2, 4 down. And we'll make -1, 8 down. There we go. Just so I can really spread this out and really get to the points. All right, so I'm going to graph these. Here we go. I'm going to draw them in red. So 0, 0. I'm going to look at my degrees and my y, or my radians and my y. So I'm 0 over, I'm 0 up. There's our first point. All right, let's go to the next one. 45 degrees over, or pi over 4 over. We're at √2 over 2, which we said is about 0.7. So let's go up and put, like this right here would be 0.75, right? This is 0.75. So let's just put a dot right below that line there, because that's pretty close. All right. Oh, come on now. There we go. Okay, let's do the next one. So let me just check them off as I go. 90 degrees, we're at 1. Okay. Now we're coming back down again. We're at that about 0.7 right there. And then we're back at 0. All right, so there's the first half of our graph. I'm going to connect it right away here just so you can start seeing what this looks like. It creates that smooth wave that we talked about. Now, if I do a good job here, I'm not doing the greatest. Oof, that's not the greatest smooth wave. It's supposed to like look like this, right? A nice smooth wave. Mine's a little bumpy, but you get the point. I've drawn worse. I've definitely drawn better. All right, let's see here. Let's keep going. So let's go to 200. Oh no, where did I get my 180? I left a point out, didn't I? Oh, you know what? I just realized why I goofed it up. I put my point in the wrong spot, that last point. Now I can see why it's not making such a smooth wave here. This point, I stuck him in the wrong spot here. Here, let's just get rid of this stuff. Oh boy, if you're following along and you're saying, Colty, you're ding dong. I can see why already. Sorry, no time to go back and redo all this. 135 was here. That's where I was supposed to have it. That's why I'm having trouble. And 180, 0 is there. That's better. Sorry guys, one take, you know? All right, so let's see. That's a little better. It's not great. I'm kind of missing my points a bit, but there we go. Best I can do right now. Hang on, let me just, I know you just love sitting there watching me draw. So I really should pause the video and do it. Okay, I'm gonna pause and come back. Okay, not the best, but I think it's better than my last couple of attempts. There we go. Now we're ready to move on properly. Okay, let's do our next point. So we got that guy, right? 0 is 180. We got him. 180 degrees, back at 0. All right, let's go. Now we're getting into the negative. So 225, we're at negative √2 over 2, so at negative 0.7 about. So let's put him right above 0.75. 270, we get all the way to our lowest point, which is -1. And we're coming back up now at 315. We're at negative 0.7 again. And we get to 360, which is at 0. Now, being able to draw this is really important, but we're going to break this down a little more. All right, now you get to watch me try to draw again. All right, so see how we're getting this smooth wave? This is one period of this smooth wave, one cycle. Okay, so we could continue. That's one rotation of a circle, 360 degrees or 2 pi to get around once, right? This could go again and again and again. So the idea is as we rotate around this wheel, looking at the y-coordinates, right? They start at 0, and then look at the y-coordinates. They get bigger, and then they get lower, and then they go into the negatives, and then they come back up again as you think about your y-coordinates. And this is the graph we would make if we only look at the y-coordinates. So again, what did we do with x, right? We made x the distance that we're going around, whether we like to talk about degrees or radians. And the y in this case is going to be whatever sine is. And sine is our y-coordinates from our unit circle. So there's a little bit of overlap there. It gets a little confusing. All right, so let's talk about the important features here. What's our peak? Well, what's the highest y can be? The highest y can equal is 1. What's the lowest it can be? -1. So that tells me my range right there. Look at our graph is a smooth curve between 1 and -1. I could say y is between 1 and -1. There we go. Those are y-coordinates, right? What about our period? The period is how long does it take to complete one cycle? Well, it depends. Are we talking about degrees? We'd say it's 360. Are we talking about radians? We'd say it's 2 pi. So I want to get them both in there right now while we talk about this, just getting comfortable with both. What's the amplitude? What's the distance from the middle to our top, or from the middle to our bottom? If you remember from the previous unit, amplitude is the radius. And in our case, we have a radius of 1. That's the same distance of here, right? It's 1 unit. So whether it's 1 centimeter, 1 meter, 1 whatever, it's 1 unit. What can x be? X can be anything. We can keep going forever and ever, right? We can go one circle is 360, another circle is 720. Keep going, keep going. We can do this forever, right? We can even go into the negatives if we rotate the opposite direction. So x, you can be anything. Now, what do our zeros mean? With sine, we were talking about, well, where do we hit 0, right? We hit 0 here at 0. We hit it again at pi. We hit it again at 2 pi. I wrote 8 pi over 4. That's 2 pi, right? I didn't reduce my fraction there. I was counting. 8 pi divided by 4, I can reduce that and just write that as 2 pi. So if some of you are wondering about that, there you go. And so on and so forth, right? The next one would be at 3 pi and 4 pi and 5 pi, right? That's when it hits zeros. It hits at pi, 0. Or if you want to do that in degrees, when does it hit? It hits at 0 degrees, 180 degrees, half a circle, 360, and so on and so forth. We're just adding 180 each time when we hit our zeros. Okay, so there's the basics of drawing the sine function, right? Let's move on and draw the cosine function. You'll notice pretty much everything's the same with the cosine function, except instead of writing sine, we're going to do cosine. Instead of looking at the y coordinates in our unit circle, like here, we're going to look at the x coordinates. And you basically get a very similar graph, just slightly shifted. Okay, I'm running the next one, which we're going to do cosine now, right? So we're going to graph the graph of cos. Okay, so I've already drawn things out. I've already created my table of values. I've already set this up this time so you're not sitting there watching me do it the whole time. But remember, all I'm doing, now what we're changing here is we're basically extracting information from the unit circle to create a new type of graph. A type of graph where we only look at each function on its own. So in this case, we're just looking at cos. So in other words, we just want to look at the x values. So I'm just using some of these points. So I'm just using the ones that are 45 degrees, right? So counting by 45 degrees, that's measuring the angle, or again, measuring the radians, which is measuring the length around the outside. It's a full 2 pi to create a circle, right? So every pi over 4, 1 pi over 4, plus another pi over 4 gives you 2 pi over 4, which reduces to pi over 2, 3 pi over 4, 4 pi over 2, which just reduces to pi. So technically everything here is pi over 4. I've just reduced some of them, right? Because this would be 2 pi over 4. This would be 4 pi over 4. All I've done is reduce. So I'm just counting by 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. So even if you're not a pro at radians, just try to be open to the idea of learning about them and not being too afraid, even if you're having a tough time. And right now, the easiest way is to keep relating them to our angles. Let's just kind of think of these things going together. If I'm at 45 degrees, I've traveled pi over 4. If I'm at 315, I've traveled 7 pi over 4, right? The radian is just how far we've traveled around, the outside of that circle. Okay, so here we go. Let's plot these points, and let's not forget that root 2 over 2, when we're doing root 2 over 2 and graphing it, that we figured that was approximately 0.7. Okay, so we said the highest we can go is 1, and the lowest we can go is -1, and that's the same thing with cosine. And we'll show that as we get going here. So let me just draw my graph, and I'm going to make this like 0.5 again, and this -0.5. Now, this is a really important graph in math, really important graph in physics. I know it's a lot, and it's really long and boring right now because all you're doing is watching me graph points, but we got to get a good idea of this. It's not good enough to just look at the final product and go, there it is. If you want to continue in math, you have to have some idea of what we're drawing here, and that's what we're starting with, okay? So let's go around and look at the possible x values. Remember, cos is the x coordinate on our circle, right? So we're looking at, but now we're going to make y, our y values, that cos, and that's where people get confused. But remember, all we're doing is cos. So let's go here. So when we're at 0, right, what is cos? Cos is 1. So if you punch in your calculator in degrees, cos of 0 degrees, it will say 1. Or if you do cos of 0 and you put it on radians, it will also say 1. Notice how radians, we don't put a special symbol. If we don't see that degree symbol, we assume it's radians. So if I put in cos of either of these, it will pop out 1. All right, and then so on and so forth. If we go to cos of 45 degrees, right? All right, let's get rid of this. So let's go to cos of 45 degrees right here. It's going to give us let me highlight it, root 2 over 2, which is the same here. So the numbers are all the same. It's just sometimes they're in different spots. So we get root 2 over 2, which we said is about 0.7, right? All right, and then you keep going. What about cos of pi over 2, or 90? What's the x-coordinate there? 0. So again, if you put in your calculator cos of 90, right? Because a lot of this we're going to do in our calculators too, right? We're not going to look at this unit circle every time, but we have to start getting an understanding how they're attached. Again, even if we're not pro at it, we have to get the idea. So cos of 90 would give you 0, right? Because that is, now remember, that's why this is where sine and cos come from, the unit circle. This is where they're born from. This is where they're from, but we're going to go farther with it. So that's why we don't have to look at the unit circle every time. All right, let's keep rocking here. Cos of 135 and cos of 180, right? Well, what do we end up with? We end up with negative root 2 over 2 and negative 1. All right, negative root 2 over 2 and negative 1. Now, these are all y-coordinates that showed up on our other graph, just in different spots. And let's go along the bottom here. I'm going to write the rest of these in, 225, 270, 315, and then back to 360. Forgot to highlight him. What are we going to get? We're going to get negative root 2 over 2, 0, root 2 over 2, and then back to 1. So let me just write these in here. Negative root 2 over 2, 0, root 2 over 2, not negative now. Negative root 2 over 2, and then back to 1. Now, let's graph this. Okay, so let's go. If I go 0 degrees or 0 degree gradients, I start at 1. So this graph starts at 1. What was the difference between that and sine? Sine started down here, right, at 0, 0. So cos starts at 1. But it starts going down right away. It goes down to root 2 over 2, which is about 0.7. So we'll say right there. So at 45 degrees, it's there. Then it goes all the way down to 0. So it starts by going downwards. Keeps going down to negative root 2 over 2. So let's see. Let's put that right, where's my halfway point? Right above the halfway point. And then finally reaches the lowest it goes, which is negative 1. And then it starts heading back up to negative root 2 over 2 again, to 0 again, and all the way back to the top, root 2 over 2 again, which is right about here, and then back to 1. All right, I'm going to pause and try and draw this thing because I think we know how bad that went last time. Okay, that's about as good as it's going to get. We looked this up online better. I'm sure we could find some better examples. So this is what cos looks like. Now here's the secret to cos and sine. They're actually the same graph, but you might be thinking, no, they're not. Sine started down here. I'm just going to kind of roughly draw a quick loose version of sine here. So sine starts down here. What sine does is it basically passes through that point, hits the top. Sine looks like this. And again, I'm just going to do the best I can here. And quick notice. This is what sine looks like. Do you see how they're kind of similar? Except cos and sine, they're just shifted. Like if we took this cos graph here, starting here, and just shifted it over, like take this point, just shift it to here, they're the same point, the same graph. Notice how this is going down, this is going down. They're actually the same graph, just shifted 90 degrees or pi over 2 from each other. That's the only difference between these two graphs. So the nice thing is they're actually pretty much identical. Because if cos keeps going, that's just one cycle of cos, right? One period is 360 degrees or 2 pi. Cos just keeps going like this, right? Sine just keeps going too. And they basically are kind of like right next to each other, like two roller coasters, one just slightly behind the other, right? Up and down, okay? So there you go. Let's just kind of get rid of all the stuff and just get back to cos though. All right, there we go. We got rid of sine. So back to cos. So what's the peak? Well, the peak is what's the highest your y-coordinates go? Once again, the peak is 1. What's the trough? What's the lowest they go? They're when y equals negative 1. So that means our range is once again exactly the same. Your y-coordinates are between negative 1 and positive 1. What's the period? Identical. It's still 360 degrees to do a full circle, or 2 pi. All right, what about the amplitude? It's still 1, right? It's 1 unit. Remember, the amplitude is the distance from the top to the center of our graph. Well, there's our top and center. It's 1. Or from the top to the bottom of our, the center to the bottom of our graph. Okay? Sorry, guys. I know I'm stumbling over my words. I've been recording videos all day and helping my own kids, and I'm getting lucid. There's no good excuse for it, but sorry. And what can x be in this case? X can be anything, because remember, x is the degrees or radians. So we can just keep going. We can just, this circle can keep going. It can go, we can go higher than 360. We can do another circle and another circle, right? Or we can go into the negatives this way and continue the graph like this, right? So the graph can keep going forever. We're just looking at one tiny snapshot, just one cycle of it. So where do our zeros occur here? Not a big deal, but remember the zeros, where do they occur? Look at 90, 270, and so on and so forth, right? They just keep coming. So we'll just put down the first two zeros we see are at 90 degrees or pi over 2. And the next one is at 270 or at 3 pi over 2. I don't expect you to memorize all that. There's lots of details here. All right, so I want to sum this up. I know this video's been too long, but I want to sum it up to like the you need to know thing, okay? So we've drawn it. We've seen how we can get values and make these. I want to just demonstrate this to you because you kind of have to know this. Let's zero in on like, if to get through grade 11 and move into grade 12, what do I absolutely have to refine this down to and know? Okay, let's boil this down to the essential information you have to be able to kind of graph. Now, those of you that continue, this is the kind of stuff you want to know how to graph off the top of your head going into university, grade 12, that you really want to know. For those of you that want to continue in math, right? At this point, if you're continuing math, we really got to start expecting something of ourselves and start learning some of these things. So what do you need to know is this. Let's start with sine. Y equals sine of x. Okay, let's start with the x coordinates we should know. We are going to just go on our unit circle. We are just going to look at these key points here, 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 and here, the easy ones, okay? So we need to know x. Let's count by 90s. 0 degrees, 90 degrees, 180 degrees, 270 degrees, and oops, that 70 is kind of messed up. 270 degrees and 360 degrees. One full circle. Okay. Now in radians, we want to start to learn those also. Okay. So in radians, it starts at 0 radians, pi over 2. So we're going to count by pi over 2. So let's add another pi over 2. What's pi over 2 plus pi over 2? 2 pi over 2, which is pi. That would be right here. So I'm just going to, there's pi over 2, right? 90. 180 is 2 pi over 2, which is pi. Then we're going to go to 3 pi over 2. I'm just counting by pi over 2s. 3 pi over 2. And then what about the last one? 4 pi over 2. Well, 4 pi over 2 is just 2 pi, a full circle. So remember, that's the difference. The one is in radians. Okay. The other one is degrees. So we want to get familiar with these really well. Okay. Just knowing these. And the nice thing is for cos, it's going to be the same set of points. So I'm going to copy that down to the cos graph. Okay, I copied those values down there, and I also wrote down, I just wrote the degrees for now on the graph. I'm a much bigger pusher and believer of using the radians, but we're more comfortable with degrees, and since everyone's at home learning this, we can stick to that a lot as long as we start getting comfortable with the radians. All right, so now, what are our y coordinates going to be? So again, I could, without me knowing my unit circle, all I have to do is to figure these out is go, what's sine of 0, what's sine of 90, sine of 180. I can just put that right in my calculator to get these out. So the nice thing is, this is basically as far as you actually have to have memorized, right? What did we do? Start at 0 and count by 90s? That's pretty easy to memorize. And if we have to know the radians, we're just adding pi over 2 each time. 1, 2, 3, 4 pi over 2. That's all this is. So the rest we can just do in our calculator if we forget. So again, if I forget, I just go to my calculator and I go, okay, y equals what sine of 0 degrees? Y equals what sine of 90 degrees? If you forget, you can just punch it in and get out your answers, okay? So here we go. So I'll just write them down here. What we're going to get is this. When we put in 0, we're going to get out 0. We're going to get 1, 0, negative 1, 0. That's what you'll get out. With cos, you're going to get this. 1, 0, negative 1, 0, 1. All right, so when I graph these are the essential bare bones graphs that like everyone coming into university is expected to know and know really well. Like if you're rolling to grade, or you're going to first year university calculus and you've never, someone asks you this and you have no clue what you're doing, this is what you need to know. 0, 1, 0, negative 1, 0. I forgot to put my 1s on here. 1 and negative 1. 1 and negative 1. All right. And this guy is going to go 1, 0, negative 1, 0, 1. All right, so your sine curve looks like this. Starting at 0, heading upwards. And your cosine curve looks like this, starting at the top. I kind of missed that there, heading downwards and then back up. Now again, when you only look at one cycle of it, they look like very different graphs. When you continue the cycle, right, like this, you start realizing that they're the exact same wave, the identical wave, right? When we do this, all of a sudden it's a lot harder to tell who's who because they're the same. They've just been shifted 90 degrees. So if we get rid of this, they look different. Remember, all this is this guy and this guy are the same. This is cos. I better write that down here, right? What's the difference? just 90 degrees of difference from here to here, right? If we took this guy here, right, and shifted him, or the other one, if we took this and shifted it back, right, or you took this guy and shifted him forward, they'd make the exact same graph. Okay, so that's the only difference. So your need to know after you've listened to this incredibly boring video is to really get to know this, okay? Write it all over your arm, write it all over your face so you see in the mirror, go get a tattoo of it, you know, that kind of stuff. These are the need to know. When we move into the rest of this unit, okay, I'm going to be starting with the graph of sine and cos every time. And I'm going to basically say reference back to that previous video. Know these two graphs really well, okay? Because every time I do the transformations, I'm just going to start with one of these two, sine or cos. Okay, sorry, super long, super boring, but I know you just can't get enough of the sound of my voice. Thanks for making it for the few of you that made it to the end.